Hello, Mr.M. Hello.
Just I try to cover everything through Google Meet.
Ramadan.
Okay, and also already I gave some of the instructions. Just you should bring pen and note, and you should bring also.
Hello.
So as well as
Ramadan.
if possible, you can have PhD design data book. Everything must. Okay. And also compared to this semester, compared to all other subjects, so you have a activity subject, probability subject. So and also I want to share something.
Madhusudanan sir, shall we start now, sir?
Yes, sir. You can start, sir. Good morning. Very good morning. Am I audible, sir?
Yes, sir. Audible, sir.
Definitely, I will give some of the.
So, good morning to everyone. So, I welcome you all for this short-term course on finite analysis on the day of 8th day, session 1. So, today, Mr. Madhusudanan sir going to take a session. So, I just give a brief introduction about the Madhusudanan sir. So today's resource person is Mr.M. Madhusudanan sir, working as an assistant professor in Department of Mechanical Engineering, near Institute of Engineering and Technology, Coimbatore. So with a specialization in energy engineering, having 13 years of teaching experience, handling thermal stream courses, especially thermodynamics, heat and mass transfer, gas dynamics, and doing research in the area of renewable energy systems and their optimal performance towards sustainable development. So this is the overall view. So sir has published many international journals, and also he attended many international conferences and published the paper. And also he has coordinated various events and workshops and training programs in their institute. So in this short introduction, so I welcome Mr. Madhusudanan sir to take over the class session, sir. I welcome you, sir.
Thank you very much, Gerald, sir. It is my pleasure to join this webinar on FEA. So I thank the management of RIT and our management also, the group of institutions, for the opportunity given for me to present the session in the webinar on FEA applications. I will be handling on FEA with heat transfer, like series extended surfaces in that area. Before that, it's a nice opportunity given for me. I wish to thank Mr. Venkatesh, who is our proud alumni of NGI, their group of institutions. So I thank him also and Gerald sir also for the opportunity. And it's nice work done by the RIT organizers in the pandemic situation. People doing wonder things which are eye-opening for students and to know things in this situation. Well, that too, FEA is a great career opportunity oriented area where if you learn basics, if you excel in that, you can get into a lot of proud moments in the area of research, especially thermal. Yeah, I'm going to give a topic on thermal or heat transfer related applications. So I will be discussing over related with the concepts of heat transfer along with it. I hope my voice is audible. Shall we go to the presentation?
Yes, sir. Your voice is audible, sir.
Thank you. Thank you. If any interruption comes, please inform me.
Yes, sir. Yes, sir.
Thank you.
Thank you.
Whether the screen is visible, sir, Gerald, sir?
Yes, sir, it is visible, sir.
Thank you very much. Thank you very much. And I welcome the participants of RIT and other faculty and students from various regions who are participants for this webinar on FEA. And Once upon a time, I was doing this course in the FEA before 2014 when Venkatesh was our student. At that time, I used to handle all finite element papers for aeronautical and naval department. And later on, that many specialized people came. So I started switching into my own area, energy related papers. So it's a nice opportunity for me to again regain back to my area of FEA with heat transfer application especially. So this will be the contents today. I'm going to, we are going to discuss on. Let's start with prayer and salutation. It's gratitude showing moment, and my topic goes like starting from FEA, FDM, FEM, FEM+CFD, and its FEA applications, advantages, what are the drawbacks, limitations, and analogies, similarities between structural and heat transfer. Mostly structural. Whenever FEA is meant, all people take that it's of structural related, but it can be used for heat transfer applications also. That we will explore today in this class. And finally, I will be discussing on problems on composite wall and fields, and there will be review and discussions. This is my today's agenda or content. And I hope students from mechanical and civil are available as participants. So my part will be for both civil and mechanical students. So let me start the presentation with a prayer. Prayer as always brings the universe and us together to get into new efforts or new ventures to get in. So I thank the Almighty and Universe for this great opportunity to present this webinar, and also I thank you all people. And I wish to tell one thing, take it as an eye-opening, or my part, I wish to present it as an the learned, what are the things I know or what I came across the topics I'm sharing. There may be some shortage of information or lesser information, or if there is any deviation in the presentation, mistakes or deviations, you can feel to give in the feedback session or while we discuss, no issues. So always learning is a great thing. So for that I wish to pray a moment. And another thing, the network coverage also. Without that and all, we cannot meet together to discuss on these topics. So prayer to the universe as well as the network actor especially. And I wish to give my salutations to three people I've shown here. The great teachers, all these three, especially you may be knowing the great public president, Dr. APJ Abdul Kalam. Uh, After his government works and all, after his presidential work, he taken teaching as the refresher, new area of to reach my young minds, students especially. So, and he left his body while teaching. That was great moment. Karmayogi, he is so. I wish to salute him at this moment. Next, second important man is Ray William Clough. He is from Berkeley University. Without him, we cannot have this webinar on FEM. The thing is, he is the founder of FEM, Finite Element Methods, in the year of 1960. So he, at that time itself, he worked for thermal analysis regions, especially thermal stresses calculations and all. He started in 1960. So I wish to give my salute to Mr. Ray William Clough from Berkeley. Third one is Mech. I hope some of you may be knowing him. He is the founder of SECMAL. Apart from all these things, he is a real hero behind the film Three Idiots. Three Idiots is a Bollywood mega hit super hit movie. It came out with a new area of learning and the passion toward engineering and all. No, though the real hero behind that film is Mr. Mech, and he is from the Ladakh. He is also an engineer, mechanical, and SECMAL is the student educational and cultural movement of Ladakh. he is from that poor, that what you call, from the rural, much rural area, no electricity, no road connections to the city, and no power, no electrical power. From that region, he took a challenge to move from the traditional educational systems to the newer area. The SECMOL is a school. It's not normal school. It's for people who has the passion to learn engineering by learning by doing method of this education system. So I request all the civil engineering students, especially, to visit the SECMOL website. There are two resources available in that area of Ladakh. Ladakh is some 3,500 meters away, above our sea level. So it is a cold desert, we can say, no rain, no water facility. So he's a real engineer, I will say. So I'm much admiring Mr. M.Ashok, a good teacher. Nearby the picture, there is a glacier you can see. It's an artificial glacier he made concept, and it's based on, in fluid mechanics we studied siphon methods and all. No, the simple concept he used the pressure difference, and he made that artificial glacier. So civil students, you should be proud that the basic concept of fluid mechanics is applied everywhere, and the structural things also. So my humble request to the students to visit it. So that's all of my salutation. So let all people should bless us with a good learning and update our knowledge in that. Next, I'll get into my part. If you look at this screen, you'll be seeing FDM, FEM, FEA, FEM, CFD, FEA. Why I given all these topics? Because always in my mind, while I hear these words or acronyms from someone who is expert, I think why these many methods should come. Why not a single method should serve all purposes? So to answer for that, you are undergoing this course on FEA for the past 8 days. I hope this is the ninth day, I think so. So you may come across. Before that, I wish to give some my own understanding points so that it's my full perspective. This presentation fully. So if any deviation or if there is any lesser information, we can discuss during our discussion and the review time. So FDM is basic mathematical methods of solving equations using finite difference method. It is with the origin from the Taylor expansion, we know it. So FEM is finite element method, which you solve differential equations, partial differential equations. And the third one is FEA. The FEM concepts, mathematical concepts, are applied in the analysis of the components products using solvers. It is FEA. So if you look at all these three, FDM, FE, FEM, FEA, all will do the job of the conversion of the physical problem where we require solution into a mathematical equations and solve and get the solution whichever required. If it is structural, you will look at the deformation. Deformation as input, then we look on stresses and the slope and forces where at, what is the deformation, those things. If we go to heat transfer, similarly, we look for thermal stresses where it happens, what are all the effects, convection effects, what is the reduction in temperature, those things we read in heat transfer part. So apart from this, other three you see it is FEM, finite volume method, and CFD and CAE. These are all the other upcoming good methods. FEM is finite volume method. It will, in finite element analysis, we have element word. We split the problem into small things and we call it as an element. But in case of finite volume method, we take it as a cell. So the main difference between this FEM, FEA, and FDM is FEM is used the conservation principles, energy part. It applies with various equation. All energy conservation related principles are applied fully. So it will solve the problems of fluid related boundary conditions easily with finite volume method. CFD is, of course, a solution for altogether in single element. It is CFD, computational fluid dynamics. As the name indicates, it is the dynamics fluid related concepts. These are all not softwares. Some of the students, while doing interview or during their interview time, students will say, I know CFD, I know the software CFD, like that they will say. Sometimes they will say, Fluent is CFD, like that. Fluent and Gambit are the packages which works on the FEM and the CFD related services, but they are not the concepts. The concepts are the shown in the picture. That is FDM, FEM, FEA, FEM, CFD. The final one is computer aided engineering. It is combining the all in one, no? The ANSYS software package everyone has come across. So ANSYS will give the solution for CAE. CAE is computer aided design and computer aided manufacturing all together, serving the solutions to the industries. So with a closed feedback, closed system will give good feedback. If there is any changes in the output, you can modify like that. So CAE is the current going trends, especially the ANSYS package is doing that. So I hope you got a refresh on these headings. Next, this slide gives the engineering analysis, how the numerical methods or differential equation solution came across. There are two classical methods, especially classical and numerical method. Classical method will give on exact solution and approximate solutions. Numerical method is an emerging trend nowadays with energy, boundary element problems, finite difference, and finite element things. So the error related, if you get, you can solve, you can adopt any method to do a problem. The only thing is the method, how it match with how it helps to solve the problem, how it adopts the boundary conditions or physical problem of the nature of the problem. Those things should be, if there is any deviation, it will strongly lead to errors like rounding errors, discretization errors, and all. So errors, to avoid errors, you have to be particular about the selection of the method, selection of the tool, the amount of accuracy required. Always you look at 100% or nearby, not deviation. So validation part will give the selection of the particular tool and the best method. Okay. So I'll go to the thing now. Why FEA in heat transfer analysis? So I gone through different materials, of course, and I got out with 4 points and more. So heat transfer analysis, why we have to go, especially the products or the components, with the performance and their working, you can understand before manufacturing it or before a prototype or modeling it. You can understand the performance and better understand, so it will lead to lesser errors of the products. So if you go to the performance analysis, there are 4 categories of various conditions: linear, non-linear, steady state, and steady state. Linear means it, and further I'm building it because so I will be bringing the temperature inside. So linear means based on the temperature, if the component property, material property, or thermal property may changes. The main thermal property we say thermal conductivity regarding the conduction phenomena. So if it changes, if it is not changing, then we say linear. If it is changing along with the temperature alone, we consider only temperature for this. So if it is changing, we say non-linear. If it is not changing, we say linear. So steady state, you know already, steady means it's with the time. If the properties are not changing with the time, then we say steady state problems. Then unsteady status, the properties changing along with the time. We'll give the initial condition. By the time unit step, we'll record the changes in the properties. That is unsteady. Most of the practical case will go for unsteady state problems, but for easiness to reduce the complexity, we go for steady and linear sometimes. Depends on the solution required and the complexity of the problem. Next one, to identify possible failure parts. Before it lead to newer materials. The required properties or required outcome of performance. If it is required, we identify the failures, what are the possible failure modes, and these all lead to newer materials like composite, like that. Nowadays composites are getting much predominant um, initiatives nowadays. So getting newer materials, there is a chance. And to optimize the product and processes, everyone wants best thing, no? So optimized product, optimized processes which lead to lesser cost, minimizing the cost, maximizing the property, maximizing the profit, and maximizing the efficiency. That is our main aim. So we take FEA in the heat transfer part as a fundamental part of the design. While doing the design phase itself, we take FEA and we apply it, and we come to know what are all the deviations or mistakes we done. Accordingly, we can alter the basic designs before getting into the other processes. Next, simulation. Simulation is it's about the looking at the virtual movements or virtual displacements or virtual functioning of the product component. So simulation also a good thing to know how what all the deformation, especially to deal with customers of the companies who do the services on FEA, and they can present it. If you show some colorful pictures, all will like, no. So similarly, not like that. It's easy to understand. We cannot expect that all the customers should be engineers. They may be from basic science or basic knowledge, but they do products with best utilities. But if you expand the pictorial representation will be easier. So simulating is another choice. And another thing, last thing is we can avoid the cost of making prototypes, and testing also can avoid. Before that you can do FE analysis and so apart from that, if you make something, there is investment. If you take some efforts during for long time, it's about time saving. So the delivery part of the product, when it should be delivered to the customer, so there are time also a factor. So FEA part, why we have to go for eliminate time, say time expensive, and to reduce investments, unwanted investments on wrong prototypes like that, to optimize the product services, to get newer materials, especially like composite materials, and to select the best analysis like nonlinear or unsteady, whatever it is, depends on the problem. Next, we will go to the next slide of applications and advantages. So, if you look at the slide, various areas where we can concentrate on using the FEA concepts for budding engineers who are passing out with BE mechanical or civil, we can look at these headings of areas where you can apply FEA, and also you can get your career if you have the passion of solving your problems to with tools like FEA and so other things like that. So if you have the passion to solve new problems, to get into new areas of uh, new adventures in the research area, can get into it. So first, I'm a basic energy engineering graduate masters. So I wish to give my importance in the area of renewable energy systems. Renewable energy systems are the future of power sources. It's something like solar. Said about the SECMAL, no, the solar actually is he done the SECMAL at the Ladakh, 3,005 meters altitude from the ground. You see, his initiative and intuition made him to self-sustained development path. So I'm much impressed with his works. He's good humanitarian and engineer, real engineer, I would say. So solar PV panels optimizing their weight optimizing, thermal newer materials, so thermal stresses, what is the temperature maximum it is getting. Like that solar panels, the photovoltaic can go. In fuel cell is another new area of research. So we can approach the fuel cell design also with the FEA concepts. Next, for civil students are there, I heard from Mr. Venkatesh. So I thought to add some civil portion. Why FEA is for everyone. Mr. Roy, he did the FEA during 1960 from the Berkeley. So at the time he started initially with thermal and structural only. So it is for everyone, concept is for everyone. So green buildings are nowadays a great opportunity provided area where energy efficiency buildings, energy conservation oriented buildings are nowadays getting boom, especially in foreign countries like in Canada and all. You have to do the plan along with the energy conservation methodologies simply to be implemented in the building. Like that, they look for energy efficient buildings. So that is also give larger areas of application. Then passive solar heating, especially SECMOL, we have done that passive solar. Passive solar heating, whenever the solar power is available from the sun, we store it in the building. Mostly in passive solar, in SECMO they are doing earthen materials, from the materials from the earth, starting from the clay, some materials and mitti. We say mitti technology made on the soil. In civil engineering, you might be studying soil mechanics. So one important thing I wish to tell one thing. Mr. Sonam, he started implementing the soil mechanics, earthen-based constructions for SECMOL because it is too cold region. It's go to -5, sometimes -25 even degrees C outside. How to have without power? How to have some insulated area inside to get warm up? So to store the energy, he gone through that France and all, Norway, Netherlands. They're doing mitti technology, the soil-based technologies. You know one thing, the France and all, they're not giving in English. The course is given in their own language. Some French, I heard in some interviews, he learned French language to study that urban construction the technologies from those foreign countries. You see his initiative and his interest toward getting up his own society of Ladakh. In such a way, he learned French and he gone through that course with that French knowledge. So, like that good teacher he is, so his initiatives are great things. Next, newer materials. Newer materials are the another finding new materials. You can find journals along with newer materials with composition difference and names also, which is a mechatronics small where the space requirements are there. We go for MEMS based products. Then it is dealing with heat transfer. So without combustion, we cannot leave this topic. Burners and combustors in furnaces and gas turbines. If you take burners and combustors, it is of with fuel economy. You know, the fossil fuels or the diesel or other things, gases, natural gases, whatever it is, they are getting day by day deteriorating. Their requirement is getting more, so they are getting more expensive. So the fuel economy saving costs are much important. So optimized best technology to be utilized in terms of fuel savings. So burners and combustors take that part in that. Then heat exchangers design and optimization. Heat exchangers apply the basic principles of thermodynamics, heat transfer concepts. There the flow can be analyzed best heat transfer with the lesser area, like that optimized we can say compact heat exchangers like that. Then of course our automotives, hybrid vehicles, where they seek for the fuel economy and also the best aesthetics for materials. So in these areas, FEA takes thermal stress analysis, those temperature dependent. No, it will lead to thermal stresses, either shrinking or expansion like that. So it depends on the country is cold or eastern or western. Depends on the climate condition. We go for different materials or to adopt different climate condition. They have to come with newer materials. So for that it's used. Other applications also have gone through from the website marine undersea related insulation systems, submarine systems also seek for the heat transfer analysis, and of course chemical plants, their processes, and the designing of the equipment utilization. These are all the areas, wide areas are there. If you explore in where we get a lot of things. The thing is, you should have the passion. I wish to do something new. I wish to solve problems. I wish to get into new knowledges. Like that, you should have the passion. It will give you good efforts to it. Next, I wondered yesterday while surfing into the net, I wish to give some pinpoint data about heat transfer, how it is applied, where and all applied. I got confusion from textbooks. I didn't get much data. But while surfing, I got this pie diagram, pie chart, which gives different areas where heat transfer thermal simulations are seen. And they sought the thermal simulation equipments. They are using worldwide, they are using the thermal simulation in these areas. You see, starting from the motor vehicles, aerospace, their jet engines, gas turbines, industrial business machines, architectural side 2.1%. Civil students, I wish to give an obligation that you people should come to the part of heat transfer analysis too, like energy conservation buildings, green buildings part. You people should come up with new research over the green building side, so that this architectural 2.1% should grow up to more percentage. And government and military 5%, others 7%. Academic institutions to do their research, they are using 7.9%. Medical and dental 11%. You see, out of these all industries, they are using more, 20% nearby. Motor vehicles 16 part. So there are wide, it shows ample opportunities in the area of research to use the heat transfer part and analysis using FEA as well as the CFD part. Also an upcoming thing. It's a good visual, so I thought to share to you. Next, some of the software packages. Sometime we come to know the softwares through software packages through the experts. So I came across this and I given the utility. Answers go for the computer-aided engineering full solution. It provides Nastron, Lisa, Adina, Comsol, SimScale, OpenFOAM. OpenFOAM is doing with FEM, Finite method. If you go for convection predominant heat transfer areas, can use OpenFOAM for Abacus, Mech, Wilson, Midas, NFX, Simulink, MATLAB, even Fluent. Fluent is the package for CFD, which can be used along with FEA for better results and better efficiency and lesser errors. So these are all the some software packages. If anything, best one left out means sorry. If it is some new things, you can add. So why we have to go for software packages? One main thing is to get into the added advantage that the deformation stresses can be easily viewed. Their combined efforts can be done easily. Only thing you should know well was giving the inputs properly and the usage of the package perfectly. And nuances, great input points, and the details of the software packages will help in good analysis. And multi-physics modeling, different phases like all three, convection, conduction, radiation, and phase change. Like that, multi-physics modeling, complex engineering problems can be done. And at the same time saving and cost saving. And then thermal fluid dynamics can be viewed easily. If you go for manual things, it is outdated, it is time consuming one. So the software packages will help you in, by communicating your ideas to the customers or to communicate better to the people around the team. If you go for research industries, there will be a team of people working together. One will not do all works. So a team will do combined efforts work. So to share your work, to share your results, and in best way, the software packages are must. So I wish to show some of the application side where the solar PV panels are modeled and analyzed. You can see the visual regarding the solar photovoltaic panels, their size optimization, material, and their deformation are all shown here. Next, automobile. If you take automobile, materials are getting much the attention. So they go for the simulation of checking failures by testing with crash, with the deforms, how the material changes. Like that, testing of automotives, it takes much one, especially thermal side also they are doing. Next, I come to the civil students. Passive solar building, SECMOL. Kindly you visit, students, please visit SECMOL. I like it much because they are doing what we are not doing. Especially the educational system in the SECMOL is common sense oriented. There is no, say, studying to the good student, studious student, slow learner. There is no difference like that there. Provided having the passion, learning by doing mentality, if you have, you can apply for apprenticeship also. Yearly ones I are giving. The building shown here is not simple construction. It is earthen building. If you see the basement, it is under the earth. Some feet it is inside, not above the earth. So earthen construction they are doing. They are passive solar heating, fully solar powered green buildings. They are well insulated to hold the thermal energy during the evening or no sun day or no solar power day. They utilize the sources of the thermal, that is solar energy. So solar energy buildings will give attention to the research on finite element analysis. Next, like this, floor, building insulation, floor thickness and material, they can be optimized by analyzing the various things. Next, this I have taken from one website related with the buildings for the Canada. Their climate is different. They look for this airtight construction, highly insulation, solar oriented facing the direction north or south, depends on their orientation, and high performance windows. So like that, energy conservation in buildings takes a new avatar, we can say. So people who are all interested in energy buildings can go through and approach with your research. Next, this is roof optimization, like that. These are for especially for civil students. I put to display. Next one thing, thermal bridging system. I don't know whether civil students are aware or you're doing, I don't know. But it is good concept in Canada. They are using in the walls, thermal insulation they are giving to store the heat or to avoid the heat or coldness from the outside, like that. The thermal insulation systems based on the softwares, FEA+CFD they are using to solve the thermal bridging systems. If you find time, you can go through the website. I will tell the organizers to share my PPT for the basic information, especially for students. You see, in my presentation, I will be dealing only basic things which I come across or things. It's not for hi-fi. I will not say it's hi-fi and all. The thing is, what I know, I'll share. Then advantages of FEA, if you take physical response, how the deformation takes place, how it responds to a problem, a product, which are all neglected response neglected in the analytical solving problems. And for dangerous areas, before making prototypes, we can have safe simulation. Some, if you go for some windmill and all, if you take renewable system, windmill takes impractical load condition, wind waves we cannot give. So like that, some impractical wave conditions, load conditions we can give with appropriate boundary conditions, and their failure modes can be studied. And with a single model, we can go for several failure modes. So it's multi-utility point to explain it, and extrapolation also you can do with the various experimental results. So far we discussed the advantages, applications, the good things, but some disadvantages, I wish to say, limitations. So where the CFD takes a part along with FEA. If you take heat transfer side, there are different modes of heat transfer, 3 modes. conduction, convection, and radiation. FEA mostly perfectly deals with conduction part, but whereas conduction radiation, their importance is less given or the conditions we cannot give without the boundary conditions which you have to get from the CFD. So where the need for FEA accompanied with CFD takes a new avatar, you can say. And so these are all the visuals where we need FEA along with the CFD to give the correct or optimal boundary conditions. There are heat exchangers shown, plate heat exchangers, and here a blade vanes in the turbines or propellers, you can say. Their thermal radiation or thermal things are shown here. So next thing is analogy. Mostly for civil or mech students, civil students will know about structural part, but I wish to share analogy, that is similarity between what are the terms similar, how to relate it with structural and heat transfer. You can see it. This is the analogy between the structural and the heat transfer problems. So in structural part, you have displacement. You give the input or condition with the displacement. Here in heat transfer, we take temperature. In displacement, you will say load, this much of the load Newton, you will say. But in terms of the heat transfer analysis, we say heat. In heat transfer, the main thing is there should be temperature difference. If there is any temperature difference between two different systems, then there will be heat transfer. Heat is positive. Heat and temperature both are different. Heat is the process path oriented, temperature is a property, which is a numerical number, whereas heat is path oriented. When the temperature is varying, we say heat is done, or cooling is done like that. Watts is Newton meter per second or joules per second. Then stress in case of structural, Newton per meter square or Pascal. But in case of heat transfer, we say heat flux. Heat flux means heat per unit area. For 1 meter square, what is the heat available? Like the heat flux, we say. In structural part, you say stiffness, load per deflection. You get 1 meter deflection, what is the force required? Like that in thermal conductivity, for thickness of m thickness for 1 degree Kelvin. Capital K is Kelvin here. For capital K, use stiffness in structural. Here, capital K in heat transfer analysis, we use it for Kelvin. So thermal conductivity is watts per meter Kelvin. You can find the values for different materials. So like that, you relate the terms. That is analogy. That is the relating the various parameters and their similarities. Next is in structural, we say stiffness matrix. Here we use the term conduction matrix. Here stiffness and the deformation and the is equal to force vector. K and matrix will be formed. Here small k is thermal conductivity. Delta T is the field vector here. Delta T is temperature difference, and F thermal is, of course, it with internal heat generation, convection, and thermal stresses. Okay. So these are all the analogy or similarities you have to know, or if you know, you can do better performance or better analysis. So we'll go to problems, simple problems. I wish to discuss two kinds of problems. One is with composite walls, another one is with fin. Composite wall fully I can explain, but for fin I have equations formulation only are given. So for FEA, FEM concepts, we have 5 steps. You have to go for 5 steps. I think you will be knowing this for the past 9 days. You got refreshed. In that first step, step number 1, you have to create the geometry for the physical problem. What it will be termed as pre-processing. So creating geometry is the first step, using models, using modeling tools, and defining the material properties. Material property in heat transfer analysis, thermal conductivity is the main property. How fast it will conduct or transfer heat. That is the quality of thermal conductivity. How fast, how effectively it will conduct heat. That is thermal conductivity. Then choose initial and boundary conditions. Define the side conditions like contact definitions and the circumferential conditions. Then discretization, of the geometry that's called meshing. So this is the first step of pre-processing. Here main thing, if you compare with structural, only thing is it will be dealing with temperature and the thermal conductivity, those properties, thermal stresses like convection, those terms will come, heat generation will come sometime. If you, for the civil students, I wish to tell something. In concrete, if you go for optimization of concrete structures, concrete structure will deal with heat generation because of the chemical reactions with the cement and all. No, so the concrete structure analysis can have the research in the heat generation part. So those things could be added in the first step. Now, second step is the element that is splitting. FEA itself, it says element. So splitting the huge problem into small elements, mostly maximum elements to avoid error or to give better accuracy. Now, after the element formulation, development of equations for the elements and setting up partial differential equations in its weak form. This is the second step. Third step is assembly of each element and nodal equations into global combined one, the entire system for one element. Next, fourth step is solving the equations either by, there are different methods. According to me, the easiest method you're studying from the school days, the Gaussian elimination and Cramer rule are the simpler ones to solve the equations. If the number of equations, number of unknowns are same, similar, 4, 4, if it is 4, 4 or 3, 3, then go for the elimination methods and find the unknown or required data like temperature at different nodes, like that you can find it. Next, fifth step. Fifth step is post-processing. Post-processing after doing analysis. If you want to represent quantities of interest like temperature at different nodes, thermal stresses, expansion or contraction like that you can study. And you can get the visualizations, pictorial images of the deformations or temperature with colors so that you can understand easily. Now we get into composite walls. Composite wall means combination of two or more materials or more than one material, you can say. Mostly, if you take the green buildings or heat transfer side, the insulation material or insulation services will where the composite wall concepts are applied to reduce heat transfer or heat loss. So for that, I will take a problem of composite wall. I read the problem faster. A wall of thickness 0.6 meter having thermal conductivity 1.2 watts per meter Kelvin. The wall is to be insulated with a material of thickness 0.06 meter having thermal conductivity 0.3 watts per meter Kelvin. The inner surface temperature is 1000 degrees centigrade and the outside of the insulation is exposed to 30 degrees C with heat transfer coefficient 35 watts per meter square kilometer. Sorry. 35 watts / meter square Kelvin. Find the nodal temperature, assume surface area is 1 meter square. Now we'll analyze the problem. It's a wall of thickness. Thickness means thickness takes the predominant in the size. It is geometry data and thermal conductivity, you know, property, material property, small k. The wall is to be insulated, so it is composite. So it's going to be attached with some other material. If you see the thickness of insulator is 0.06 thickness is added, its thermal conductivity is 0.3. You see lesser thermal conductivity. It will not conduct much heat. So if you look at the wall thermal conductivity is more 1.2 watts per meter Kelvin. The inner temperature is 1000 degrees C and the insulation is exposed outside the atmosphere 30 degrees C with heat transfer coefficient 35. This heat transfer coefficient 35 watts per meter square Kelvin. It is the convection parameter where the solid and fluid interacts, so that we will discuss. So this is the description of the problem, physical problem into a diagram or model, we can say. Inside temperature is 1000 degrees C. There is a wall. It has a thickness 0.6 meter. It has the thermal conductivity 1.2 watts per meter Kelvin, and the insulation is 0.3 watts per meter Kelvin, and its thickness is given. There is a convection that H watts per meter square Kelvin. Sorry, there is a mistake in that. H is equal to 35 watts / meter square Kelvin, and the surrounding temperature T infinity is 30 degrees C. You see, while we do the temperature analysis or heat transfer analysis, you see one important thing here. 1000 degrees C is one side. This is higher temperature. Another side, the another end is T infinity. That is only 30 degrees C. So there is, you see, a huge temperature difference is there. So as per the second law of thermodynamics, heat always flow from low, higher to low without any without any external service or device or markup. So it will automatically flow from 1000 degree to 30 degree C immediately. It will take, you can see the applications of this problem. It may be a furnace, valves, there are heaters available. The heat inside should not go out. So we have to protect that heating part to the insulation is provided, that the convection should not happen. That is, the atmosphere should not take the heat energy outside. If it is taking energy, means it is in terms of fuel consumption. More fuel consumption and more energy loss, more costs, like that it will go. So insulation is a predominant thing to avoid the heat losses. So here comes our finite element. I am splitting those two walls into, for simple analysis, I am taking it as two elements. First element is with nodes 1, node 2, node 3. There are 3 nodes, 2 elements. First element constituting the nodes 1 and 2, T1, T2. I am giving the nodal temperatures, and element 2 has the nodal temperatures T2 and T3. I have given the notations in the while modeling itself. You give the notations in order to use it easily during the solution side. I've given the things here. So there are elements, 2 elements, and nodes are 3. Now we get into the equation, finite element equation part. So to give the better idea of what is the principle behind the heat, if there are only solid part or fluid part within molecules, if the heat is, if the temperature changes step by step, or if the temperature is changing or conducting through the material, then we say it is conduction. There is no either material of solid or fluid. There is no combination of fluid solid. So only here first element is wall. So I'm considering only the conduction part. So Ka by stiffness, thermal stiffness matrix, and the temperature variables, and the force vectors in terms of thermal force vectors, I'm getting equation. This KL 1 minus 1 minus 1 1 stiffness matrix is based on the Fourier's law of heat conduction. So it is a term which indicates the conduction phenomena. Next, we'll apply the conditions given in the problem 1000 degrees to convert that into Kelvin, because wall thermal conductivity is given in watts per meter Kelvin. So the linear dimensions, geometry data, you have to convert it into meter. So that part you can substitute and get the equations done with a small final matrix 2 minus 2, 1 to 1073 and T2. Now we go to the next element with nodes 2 and 3. Here there is at the end there is a convection, a fluid contact is coming. So H is equal to 35 watts per meter square Kelvin. That watts per meter square Kelvin it is. So here the equation changed. There is convection part is to be added. This term is due to the convection around the circumference, around the end convection and the surrounding, as well as the force vector on the right side. It gives the HA T infinity, that is, it is a convection coefficient. So convection law applied, that is Newton's law of cooling, Q is equal to HA delta T, and conduction part will go for Fourier law of heat conduction. Based on that, these equations are used. Now the simplification, substituting the material data and the thermal property data, we are simplifying step by step. These are all you can do. The only thing, what is the terms you are assuming, what is the phenomena you are taking into account, and what is the equation you are using, that will give an effect over it. So step by step, you have to be careful with the units while substituting. Thermal conductivity is watts per meter Kelvin, area is meter square, and L is in meters, and H is watts per meter square Kelvin. Temperatures are in Kelvin, and area is 1 meter square again, and the T infinity is also in Kelvin. So this is the final equation for the element 2. Now the finite element terms for the element 1 and element 2 are shown here. Now global, a combined equation. By coupling the matrix, we get this final equation, and by solving either by numerical methods of Gaussian elimination matrix method or Cramer rule, you can adopt and you can find the terms T2 and T3 like this. So you should get the practice, or if you are already studied FEA means, um, you will come to know the difficulty of solving manually the problem. But the thing is, by practice, you can do it by more exposure to it. Now we go to the fins or extended surfaces. Extended surfaces or the taking great part, like engines you can use for heat transferring from the surrounding of the cylinder. There are some projections, metal projections that you might see. Those are all called as fins or extended surfaces. It takes much energy part, that is to make the material for long run. To protect it, it should be properly relieved, or some heat should be relieved properly. So for that, for extensive heat transfer would be, whereas common composite was dealing with insulation, but whereas fins it's dealing with, we want heat transfer more to cool the product. In engine, the surrounding material projections are given for the material projection for the faster cooling. So the material will be going on cyclic processes now. Continuously we are using the cycle and the engine. So it should be cooled properly to give the equilibrium condition or something. So here heat transfer should be done more. So this is one of the FEA or this software package output. Now we go to the problem. The one rectangular fins problem you can see. The fin is rectangular in cross section with 8 cm long, 0.4 cm wide and 1 cm thick. It's fixed to a wall at 80 degrees C. Assume that convection heat loss occurs from the right end of the fin. Determine the temperature distribution of the fin using the following given boundary conditions. Thermal conductivity is 0.3 watts per meter Kelvin. Convection heat transfer coefficient is 0.1 watts per meter square Kelvin, and the ambient temperature is 20 degrees C. So for this, we make a physical modeling which adopts the problem statement. So this is the drawing. So fins are nothing but material parts which are connected to huge temperature area 80 degrees C, and the linear geometry dimensions are given. The thermal conductivity K is given. H is convection, that is on the right side. Air will contact the fin 8 cm long, so that component is H, convection term, and the atmospheric surrounding is 20 degrees C. It is also given clearly. Now we relate it with the finite element. We split the 8 cm long fin into, there are 4 elements. 4 elements, it's split into equal distances, 2 cm, and there are 5 nodes. Starting from node 1, get the basement temperature 80 degrees C. At the free end, till nodes 2, 3, 4, 5, you have to predict, or you have to calculate the temperatures. T infinity is the surrounding temperature, it's quite away from the node 5. So it is given clearly how we split the given model into finite element model with the nodes and the elements. It's all given. Next, in this basic, before I told about the Fourier law and Newton's law in the previous one, here you can see it easily. That is to understand, to apply the conduction path, the basic equation is Fourier's law. Q is equal to minus Ka dt by dx. And Newton's law is Q is equal to HA Ts minus T infinity. So if you look at the equations, if you refer the Newton's law of convection, there is solid and fluid is coming. Ts is for solid surface and T infinity is for fluid. For conduction side, either solid or fluid, either one you take and analyze in the material molecule level. Now the equation we see for the element 1 between the nodes 1 and 2. If you see the finite element equation, there are different components in the equation to add the effects given in the problem. First thing is conduction part. To give the conduction part, I'm using A by L, 1 minus 1 minus 1 stiffness matrix, thermal stiffness matrix, conduction stiffness matrix. It is based on the equation Q is equal to minus Ka dt by dx. Next is peripheral convection. The peripheral means circumference side. It is open to atmosphere, so peripheral convection is to be added. Further, based on the Newton's law of cooling, we are taking the equation or component HPL by 6, 2, 1, 1, 2. For these two, both the terms, we have the common nodal temperatures T1 and T2 is equal to the effect of the end convection. End convection means from the atmosphere, what is the effect apart from the circumference. So HPL, P is perimeter, L is the length, T infinity is given. So like that, different terms should be accounted to give the full representation of the problem in order to get the proper analysis. Now similarly for the element 2 and the nodes 2 and 3, it's given same things with different node temperatures T2 and T3. Now it is for the element 3 and 4 with the same equations. Like that you can apply. And the next one is for the element 4. Both 4, 2 or 3 and 2 and 3 element equations are similar, but if you take the element 4, on the side of the node 5, there is comes the effect of convection, end convection from the right side. So that the Newton's law of cooling equation based convection, the lower vectors should be added on the right side, that is HA T infinity and HPL T infinity by 2, 1, 1, that is column vector. So like this, we have to formulate equation based on I said about 5 steps now, starting from that. But after forming the elemental equations, you have to globally make the coupling of the equations and make into the vector component, that is matrix form. Then we will solve the equations to get the unknown nodal temperatures and all. So with that, I'm stopping the analysis part, total how to approach and all. Now let me go to the review side. What I have discussed so far from the beginning. It's about an introduction about the finite element analysis from the FDM, FEM, FEA, CFD, and FEM point of view, how it differs from other elements. We have discussed in that. Then application side also we have discussed, and numerous applications are available. There are only architectural side, we have seen only 2% of people are doing research or using thermal analysis part. So I humbly request the civil students to get into the transfer or insulation green building side research to make use of FEA concepts. Then limitations, we have to go for CFD no other way to make much efficient FEA outputs. So we have to go for, to give better boundary conditions, to give suitable boundary conditions, we have to go for CFD, and the tools are, nowadays Gambit, Gambit is modeling tool, Fluent is the CFD using solver, and ANSYS gives all utilities. Student versions are also available in the website, you can download for some trial period and given to utilize the resource and learning materials on the website. Then we have to understand the analogy, similarity between the new technology and the old one, so that you can utilize the ample opportunities available for the research. Then we have seen problems. Problems I couldn't do much because it takes time to solve, long time in doing so. I couldn't make the equations in the form, digital form. We are also learning, to get into digital and typing and all. I'm learning that equation side part also. In future, if I get an opportunity, I can do it more the thing. Next, these are all the references. Kindly, I request the organizers to share this PPT to them to get the references links I've given. Mostly I use online resources. So these are all important links. You can get more information what I have given today. More than that, especially Digital Engineering 247, it's a good website and sincere also. Kindly students go through these websites to get to explore and to more details you can get it. Of course, this is important. My request to visit the SECMOL website and videos which will motivate you toward the passion of engineering, to work more, to research, to learn more, not blaming all the situations, pandemic and all. Take this opportunity to learn up and get more opportunity field and explore your area of research. So I thank everyone for the patient listening. I don't know how much I covered the portions, but I had said what I know, what I learned or what I came across. I just shared with you. So in the feedback side, please give your open feedback, freely in the feedback form so that I can listen to it, I learn and grow. We all defeat the COVID situations by using our time, using these webinars like your institution RIT is making great initiative for the learning platforms for you. I hope all you will explore it and use it, get benefited. Thank you very much once again.
Thank you very much, sir. So it's very nice presentation. So I
Yes,
have watched from the beginning. So
yes,
your explanation is very nice, very useful for every person. So that we have received so many positive feedback, sir. And
thank you,
also
sir. Thank you very much.
two
Thank you.
there are two questions from participant side, sir.
Yes, sir. Yes, sir. Yes, sir.
One is
I'm
from Arun Kumar. So he's asking about the conduction matrix value. Why we are having one, and also another
one minus
question.
one.
No, sir. Only in conduction matrix, only the induction is one.
Yes,
That
yes.
means
That
and the
matrix value is 1, 1, you are telling.
why we are getting
For
one. In convention
yes,
matrix, why we are
yes.
getting zero. This is the question of Arun Kumar.
Yes, sir. Yes, actually, if you look at the elements, there are two nodes. There will be for each node, the conditions are applied, equations are formed. So for two nodes, we get only two equations. Those equations are converted into matrix form so that the elements are 1, 1. We took the common term outside. If you apply the temperatures T1, T2, there will be difference. So by taking the common elements out, there are 1 minus 1 like that coming. The temperature difference is the main phenomena in the conduction part, so that the difference is given as in minus. But in case of conduction part, why it is coming zero? Because we are giving only on the conduction. At the end of the conduction, at the end of the side, from the right side, we are adding conduction phenomena. So that other terms we made zero, and only where the option is given, we add. That is the explanation for that, according to me.
Yes, sir. Yes, sir. So it is a questions from participant side.
Thank you, sir. Thank you.
Okay, sir.
And another request, sir, from my side,
Yes, sir.
especially you make one presentation and before the end of this webinar, total
Yes, sir.
webinar after 12 days, no?
Yes, sir.
You kindly show that details of that SECMOL I told, no, sir. It is one of the inspirational website the students, especially for civil students, they'll get motivated bunch.
Yeah,
So
okay, okay, sir.
that's my humble request. At the
Present.
end of 12th day, 12th
Yes,
day
sir.
you can make it.
Yes, sir. Once again, repeat, sir. What content, sir? Small.
Actually, it is SECMOL
Small.
website is there. I've given in the references at last.
Okay, 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 sir.
Some
I will take
videos
it.
also there.
Yes, sir. Yes,
It
sir.
should be given to the students of civil department especially.
Yes, sir. Yes, sir. Yes, sir. Okay.
Because learning by doing method is much effective for slow learner. Students may be of slow learner or studious, but the system side, the problem is from the system side or education side. So that every humans can adopt the passion toward engineering. That is a concept in psychology. So they can utilize that opportunity for the time.
Yeah, yes, sir. Yes, sir. Uh, so now open to audience. So if you are having any specific questions, you can unmute your mic and you can ask the questions directly to the Madhusudan sir.
Especially some civil students ask me, I'll be happy if they got some links, points from that.
Yes, sir.
Mechanical will do well. They are always
Yes,
talking
sir.
on
I
CAD.
put my question in chat box, sir.
Okay, okay,
Already.
sir. Yes,
Yes.
in Aryan having some questions, sir. Um,
What is the question?
how
Can
to,
you read? Could you please read it?
yes, sir. How to get the conduction equation?
That is actually derivation part is I have not covered because of the time.
Yes.
Uh, you can go through the Dr. Jane Reddy book. It is fully with basics of equations. You can understand better than me. So better than my presentation, you can understand it. I hope you have that book of, or you go through the Digital Engineering 247 website and give detailed derivations of it.
Yes, sir. Yes, sir. One more question, sir. Reserve
Yes,
Saraswat. He
yes,
is
yes.
asking about the heat transfer analysis is worked on both the finite element analysis and the finite volume analysis.
Yes, yes, yes.
Is it correct or
No,
not?
it is actually finite element analysis. There is a problem of the conservation equations are not coupled with the software packages. Whereas if you go to finite volume method CFD, their basic methods itself tells you to adopt the Navier-Stokes based or the conservation laws, energy. They are taking on the concept of cell. If there is one input, there should be an output like that finite volume methods. Okay, so that
Yes.
conservation terms are included in that. That is a specialty of finite volume element. So that you can give the better, best boundary conditions. To identify closest boundary conditions can be done with FEA. Apart from the CFD, FEA can be accompanied with CFD like Fluent to get better boundary conditions. But both are different. FEA is with elemental, but CFD is with finite volume method. It's with cell based. The main thing is conservation equations are used in the finite volume to add the conduction, fluid solid interaction. That's the main difference.
Yes, sir. Thank you, sir. Thank you, sir.
Thank you very much. Thank you.
This is the questions I have seen in the chat box, sir.
Thank you, sir.
Participants, if you have any specific questions, you can directly unmute your mic, then you can ask your question.
Especially, I want to know how civil students are looking at this FEA. I've seen your YouTube page for RIT
Yes,
about
sir.
the various civil faculties taken some FEA sessions in previous some May month. I've
Yes, sir.
seen some faculties with good explanation and all. How
Yes, sir.
these students are approaching for FEA, civil students especially.
Yes, sir.
Anyone done projects like that?
In our group, both mechanical and civil students are here, sir.
Okay, it's
Majority,
good effort, sir. I've not seen like this. CAD department is taking both civil and mechanical team together. That too in YouTube, I've never seen. Colleges adding the resources. So students are very lucky to have the resources much RIT. So it's good to see. So I'm happy. So that I accepted Venkatesh for the presentation. Otherwise, mostly I won't go for presentation like this. I used to go for paper presentation seminars, but not
okay.
given concepts of books or course side outside. This is the first time.
Thank you very much, sir. So we
Okay,
are taking
okay.
some effort, sir, for making
Hello,
this
sir.
awareness.
Hello,
awareness.
Yes,
hello, sir.
Rishav,
Only
yes, tell me.
please again tell the name of website and who we speak.
Which
Yes,
one?
sir.
Website name.
Digital Engineering 247, you can see. Oh, this
Digital
one's
engineering.
is digital. You're civil student, huh?
But sir, you speak igma
Yes,
igma.com.
SECMOL, SECMOL.
Sir, please type the spelling of the website name, sir.
It is given
Chat
in
box.
the, I'll put it in the
Yeah.
chat box, okay?
Yes, I will share this
The
very
PPT, so that
uh,
is easy. It's easy,
Thank
you
you, sir.
have to go through people.
Thank you, sir. Thank you, sir.
So
yes, sir. Yes,
I've
sir.
given in that chart. It is of student education and cultural movement of Ladakh. That is a full form of SECMOL.
Yes, sir. Yes, sir. Yes, sir.
By looking at the website itself, you will feel much low because we have nothing doing while comparing to that. Without electricity, without road facility, no, without basic resources, they are living with just like a king. They are living self-sustained systems, SecMol. So civil students, please go through it because green buildings coming up with thermal bridging and all. Please have the research area kindly catch that during this pandemic situation. Learn much basics and learn different tools so that you can succeed or you can get good opportunities for research.
Yes, sir. Yes, sir. So now I posted that website link.
Yes, sir. Yes, sir. I've
Sir,
given, yes.
yes, sir.
Videos you can see. Mr.M.Ashok video also will be there. Your students also can have, if anyone from North can approach for apprenticeship during their leave later on the situation, they can apply for all over world. People are coming and to learning by doing method of doing the projects and all. They have done different self-sustained toilets, bio-toilets. They are made without water. I don't know what is the technology. The technological parts are not discussed in the website. But the thing is, they posted the diagrams. If you look at the videos, you will get more information. Students are talking about their experience and all.
Yes, sir. Yes, sir. So I think there is no other question. Um, yes,
Thank
sir.
you. So
So,
no problem. They
yes,
can feel free and they can post the questions in the feedback also. I'll explain or I'll give the resources or links at least to them to explore more. One thing I want to share that always learning is continuous. Don't stop learning because of the pandemic. This is the right thing to take positive effort of learning, understand the people relationships, and learn more. Kindly abide by your faculties. So they are taking great efforts that too during this time. So kindly go with the way of them to get benefited.
yes, sir. Yes, sir. So I need to thank you once again, sir, because I inspired your presentation, sir. So you
Thank you very
clearly
much. Thank you.
explain
Because
your.
my way is not hi-fi and all. I touch with the basics. What I understand, I'll share.
Yes, sir.
That is
I
my
clear.
way.
This
Yes.
explanation is very easy to
Yes.
understand, sir. So you
Yes, sir.
clearly mentioned the
That's
simple
all.
problem,
So that
and
I am
you.
not. Yes, sir. Yes.
Yes, sir. I really inspired, sir. So I in future coming session also I will need to make this kind of presentations. I think so,
Sure,
sir.
sir. Sure. Everyone can learn, sir. Everything is for everyone.
Yes, sir.
So
Yes, sir.
it is open to everyone.
Yes, sir.
Please clear my doubt which we put on the chat box, sir.
Which one?
Sir, was
Which one? What's your
finite
name?
element method is organized for or not?
Which one?
Yes, you ask once again in
Rishav,
your.
Rishav Saraswat.
Yes. Yes, sir. Saraswat, again you ask once again.
He's talking, asking
Sir, I
about
put
CFD.
in the
CFD
chat box.
fluent based
Yes, yes.
possible.
Yes, sir.
Sure way. Sure, the
Yes, sir.
webinar will be conducted by your faculties, great faculties of RIT.
Yes, sir.
So the main thing is students will get benefited, make use of this pandemic COVID as a learning thing. While during the salutation side, I put Dr. APJ Abdul Kalam sir's picture because he is the one visionary who always dreamed of 2020. But people are saying this 2020 is taken as a discomfort year, but it is not so. It's actually rejuvenation time for us to think of revamping the education systems or getting into new concepts, learning much, especially faculty side. Even myself, I learned for the past 100 days. I couldn't. I took some time to switch over to digital form, presenting online and all. Even my conventional teacher, I used to have the board and chalk talk method. So now I am exploring new tools like Google Meet, Zoom, and all presentation tools, Jamboard, WebEx, YouTube videos, and all exploring. So I'm happy that we have to adopt the situation and we have to make open our ideas to catch the points whichever help the community and to solve the problems of people.
Yeah, yes, sir, yes, sir. So the
Or
question,
I
yes, yes,
really
Vishwa.
want to learn EFD finite element, finite volume method.
You can finite
So, sir,
volume
is
method. You
there
can go
any
for finite
similar?
volume method. You can use the book of Anderson. CFD is the better understandable book is the Anderson Computational Fluid Dynamics by Anderson.
Yes, sir, yes, sir.
It's
I have.
in line with the Fluent and Gambit. Accordingly, the various methods are given
Yes,
in
sir.
that textbook. Anderson, Computational Fluid Dynamics is a good book. Everyone who are here, I wish to know that the students are who are really passionate toward research are joined today. So I wish them to go to have the book like Bible or Quran, whatever Bhagavad Gita. They should have the book of
Yes,
research
sir.
like J.N. Reddy book for finite element and Computational Fluid Dynamics by Anderson. They should have this book. At least software packages like ANSYS, they can download from the website itself. ANSYS website, student versions are possible in the website. From your
Yes,
CAD
sir.
center, you can get them, those things, you can use it in your laptop. At least some hands-on experience you will get. Of course, Gerald sir and all are taking the hands-on sessions. Kindly make use of it. Don't miss these opportunities. My humble request to all the participants.
Yes, sir, yes, sir. One more question from Arun Kumar, sir. Mr. Arun
Yes.
Kumar asked that which is used to FEA subject in the difference between civil and mechanical department, sir.
Civil and mechanical like that, there is no textbook. I told no, you start from the reverse. That is like reverse engineering. You go to the application side first. I told about passive and green buildings. No, it is about the thermal storage. How to store the solar energy when it is available, and when it is required it should be used, just like our fridge refrigerator. Whenever we require, we use, from that we keep again. Similarly, for that we require electrical power. No, instead of that, the building itself some stored energy by using insulating materials, different materials, earthen constructions. Using the earthen available materials, we go for construction research. So that is a secmal website thing. So there is no difference. You come from the reverse. You go to the application side. Look at the problems, where the problems available. And then you approach with the materials of your or new concepts, which will give the solution to those problems.
Yes, sir, yes, sir. So I think all the questions were answered, sir. So I
Up to
thank.
my level, I have explained. It's not full. I don't know, but
Yes,
some eye-opening you will get. I can say that you can learn everything from internet and books and
yes, sir.
faculties also.
Yes, sir, yes, sir. So first of all, I must thank Mr. Venkatesh to suggest this nice kind of person.
Actually, I wish to thank him because our proud alumni, Mr. Venkatesh,
Yes, sir,
who
yes, sir.
passed out in 2014. He was one of the toppers in the class. I have
Yes,
handled him FEA and fluid mechanics subject. Both I have handled for that sector. But
yes, sir.
later on, because of the experts coming for that subject, I stopped that. Then I switched to my own energy engineering, thermodynamics, heat and mass transfer, like that I switched. So it's a nice opportunity for me to revive the concepts and get into the research.
Yes, sir, yes, sir, yes, sir. So thank you, sir. So
Thank you very much, sir.
thank you very much, sir. Thank you for your valuable time to spend with us to explain about the basics of heat transfer problem, only and fin problem, sir.
Actually,
Thank
film
you very much.
problems yet to do more. Students
Yes,
after completing the course will understand better solvers. I
yes, sir.
hope so.
Yes, sir, yes, sir.
Thank you very much. Thank you, everyone.
Thank you very much, sir. Thank you very
Thank you.
much, sir.
Thank you, sir.
Uh,
Thank you,
Mr.
Vishal.
Mr. Rishabh Saraswat, you asked one question. In future, is possible to
Yes,
organize
sir.
a webinar about CFD fluent finite volume method? Yes, we consider your request. So after completing this webinar, this series, short-term course series, so we will try to make one webinar in especially for CFD. In our side, Mr. K. Amudan is working on the CFD, so he is expert
Good,
on
good,
that.
good.
So we will make on that course. Don't worry about that, Rishabh.
So, my all the very
Thank you,
best
sir.
for the future
Thank you,
webinar,
sir.
sir. Thank you very
Yes,
much.
sir. Thank you.
Thank you, thank you,
Thank you
thank you
so
very
much,
much.
sir. Thank you. Thank you.
Thank you, sir. Okay, sir.
Thank you, sir. Thank you, Madhusudan, sir.
He left the meeting, Venkatesh.
Gerald, sir.
He left the
Few
meeting.
minutes,
Yes, yes.
Okay, sir. Okay, I personally call him on the chat, sir.
Okay.
Now only I joined, sir.
No problem, no problem.
I completed my classes.
Yes, okay, Venkatesh, okay.
Okay, sir. Today nice session, sir.
Yes, yes. Yes, Venkatesh. Yes. Whether Amadhan is there?
I think he went out, sir. I think.
Okay, no problem, Venkatesh. So we lined up here. So participants, afternoon sessions, we are having in deep analysis on composite wall problem, and also yesterday I left one simulation process, and again I will take that simulation, but I will take only 10 minutes or 15 minutes for complete those simulation regarding the model analysis and transient and harmonic analysis. Okay, now we wind up the entire session. So thank you for all participants.